Okay, so the first one we want to do here is a scatter plot. And a scatter plot is good when you have two continuous variables. So you have like an X variable and a Y variable. A lot of times what you're looking for is some kind of a relationship between those two variables, sometimes a balance between those two variables. And a lot of times you're looking to identify clusters or patterns in the data. So in other words, um, is there is there a pattern between the data points in this direction, this direction? If you see the data forming kind of a line of dots, then you can say that there's probably some kind of a pattern there. Okay, so and another thing that's interesting or useful with this is detecting things that are way outside of the pattern. So you can instantly see things that are way outside of the pattern with a scatter plot. So let's take a look at a scatter plot here. And I am going to start out using that same data set that we played around with last time. It is from about 10 years ago. Okay. Actually 12 years ago. It's like 2010, 2012, I think, that range. And it is a set of data that talks about career outcomes for different college majors. So it has a list of college majors, and for each college major, it has its category, it has a total number of people that majored in that, it has a total number that were employed, it has employed full-time, unemployed, unemployment rate, the median income, which is the middle income for that, the 25th percentile, the 71st percentile, and that's it. So the 71st percentile is kind of like the higher end salary for that college major. Okay. So what I'm going to do first is that's a big data set. So I'm going to get rid of some of this stuff. And so the first thing I'm going to do with that data set is I'm going to take that data and I'm going to create a smaller data set called EMP. And I'm going to create it with just the major name, how many are employed, how many unemployed, the total number of people, and the median income. After I get that, I'm going to sort it by median income from top to bottom. Okay? And then I'm going to display that. So I'm going to run that code. And there is the whole data set. Okay, it's got I think 137 lines or something around that neighborhood. Now it's sorted from the highest median income to the lowest median income. And you can see some of the petroleum engineering, pharmacy, science and administration, marine engineering. Got a lot of engineering here, mathematics and computer science in there, astronomy and astrophysics, a lot of science, a lot of engineering. Not a huge surprise, right? The more difficult majors are on a higher demand and therefore get more money. So this is the whole data set now, which is nice because I can see what I'm working with. And so now what I want to do is I'm going to slice the data a little bit because it's still, for the purpose of some visualizations, it's still a little bit too much. So I'm going to create another column and I'm going to call that EM ratio for employment ratio. And basically what that means is I'm taking the number who are employed and I'm dividing it by the total number of people from that major. So it'll come up with a fraction or a decimal that's less than 1. If you convert it to a percent, it would say how of the number of people who graduated with this major, what percentage are employed, basically. So a higher number is obviously better, but I'm going to add that as a column. So that'll be a column that I add. And then I'm going to get the top 30, and I'm going to put that into its own data set called top 30. And I'm going to rank them. I'm going to get the top 30 EM ratio, or so employment ratio. So I'm going to use emp.n largest 30, and the column that I'm going to use, I'm going to do the same thing, top 10. And then I am going to get the top 10 total number of people. So the top 10 most common majors and the bottom 10 by getting n smallest 10 on the total, which is the total number of people who majored in that. And now I have those data sets, and I'll show you the top 30 here. Okay, so this is the top 30, and you can now see the employment ratio. Now here's an interesting thing, right? Educational administration, supervision, and geophysical engineering had 0 unemployed. So their employment ratio is 1.0. Is that likely to be true and on a global scale? Probably not. But that's the numbers we have. So we're gonna go with it. But if I was doing this as a real study, I would be really checking those numbers again just to make sure that we have the right ones. This would be a data source problem. But pharmacology has a 98.3% employment rate, which sounds really good, but keep in mind, only 3,481 people are currently employed out of 5,000. Or what does that say? This is something else. Oh, this is part-time employment also included here. So it's this plus this. So it's 34. So there's basically 2% unemployed out of about a little bit less than 4,000 in pharmacology. But if you look here at nursing, there is 1,325,711 people employed in nursing. So we're talking about huge differences between those two. But you still can't look at this data and say, well, I really get what's going on here. Even though we've reduced it and cut it down to only 30 rows and all that stuff, we really don't know yet. So let's make our first plot. Okay, I'm going to import a module called plotly.express as px. That's what we'll be using for all of these plots. It is really simple and amazingly easy to use. So I'm going to create a figure equals plotlyexpress.scatter. That's the type of plot. I'm telling it the data set. I'm going to use the top 30. I'm going to use X. The X-axis is going to be the median income, and the Y-axis is going to be employment ratio. So people who are higher up are going to have better employment. People who are further over this way are going to have better money. So if you're up in this corner, you're winning. If you're down in this corner, not so much. Okay, and text, we're gonna label each data point with the major. I'm gonna set the height of that plot to 900. So that's it. 2 lines of code to make this plot. Okay, so I wish that I could zoom in a little bit better. I know it's rough on the eyes here, but down here you have petroleum engineering. Now, here's an interesting thing. Petroleum engineers make a lot of money, but what can we say about their employment? It's pretty rough right now for petroleum engineers, which makes sense, right? We're all converting to green energy, solar, wind power, all of these non-fossil fuel alternative fuels, alternative energy sources. If you're a petroleum engineer and you have a job, you're making a lot of money. But your odds of getting, and remember, these are the top 30. If we want to, let's scroll up and play around with this a little bit. Let's change that to the all of them. And I'm going to get rid of the text here because it'll just make it too hard to see. But this is all 137 of those. Okay, so this might be the best job you can get. It's got a pretty high income all the way over here. It's got a much higher income, and it's got a pretty good salary, right? Because it's closer to the top. If you're willing to risk it a little bit, right? Actually, this is a safer job. Okay, you're willing to give up a little bit of money here. Let's see how much money you're giving up. So this is still over $80,000 a year. And we don't have anything here that says what these are. So let's put the text back in now that we've taken a look at it. Text equals major. Yes, I did forget a comma. Thank you. All right. So there's all of them. And this is where the zoom in feature really comes in handy, because if I want to zoom in, I can start seeing how these things stack up. And notice it changes the scale down here at the bottom. So we've got a lot of jobs grouped around the $50,000 and pretty good employment. You can see a little bit of a trend, right? You can see a bit of a line here, or you can imagine it. But right here, petroleum engineering is all the way out here. If I'm willing to make a little bit less money for a little bit better job security, then geological and geophysical engineering is for me. Educational administration, again, a pretty safe job, but not making too much money. It's education. You don't expect to get rich in education, right? I can vouch for that. Nuclear engineering is a good one. Of course, there's that ever-present risk of all your hair falling out. So you have to weigh the cost a little bit. So that is a scatter plot. And you can kind of see the value there, even with a whole lot of data. It's pretty interesting and useful.